Ladies and gentlemen, welcome back to the shop. Today I want to start working on a backing plate for this little 3-jaw chuck. Now I don't want to do a standard backing plate. I would like there to be somewhat of adjustment, similar like what you would get with an adjustable chuck from buck, bison, or gator. And the way I hope to accomplish that is with a 2-piece design. I will have an inner ring or an inner adapter made from this pre-manufactured backing plate that I got from a little machine shop, and then bolted to that will be an outer ring that I'll make from this ductile iron that I got from McMaster Carr. And the way that it'll work is I'll have 4 set screws set 90 degrees apart on the periphery, and then that'll allow me to adjust the chuck similar to how you would adjust a workpiece in a 4-jaw chuck. Now, the only issue that I foresee with this design is whether or not I'm going to be able to hold a 0 when I take the chuck off and put it back onto the lathe, because of the way that I take the chucks off the lathe. The way that I get them off is I lock the spindle and I put a wrench on one of the jaws and lightly bump it with the palm of my hand to break the chuck free from the spindle. Now, with the way that I take the chuck off, that could jar it and lose its 0. And if that is going to be an issue, I'm hoping to be able to solve that by drilling a hole in the backing plate in this area and then using a spanner wrench to get the chuck off. So the first thing we need to do is we need to get this backing plate to fit on the lathe. It already has the 1.5" 8 threads, but this register here needs to be opened up a little bit to be able to fit onto the lathe. So let's go ahead and do that, and I'll see you at the lathe. All right, I measured both this bore and my spindle, and this bore is exactly 1.5 inches. My spindle on the back side of the register is 11 thousandths over 1.5 inches. So we need to take 11 thousandths off the diameter, and then it should slip right on. All right, I'm set up for the next operation. What we're going to do now is turn down a recess on this side, which will be 3/16 of an inch deep going in that direction, and then to a total depth of just above this radius that's on the inside corner of this adapter. I'm sure that radius is different on every adapter. I just want to leave that radius, so I'm just going to plunge to it. .329, and that is the diameter right up to that the edge of that radius on the inside corner here. So for this part, that that's it for the machining on the backing plate for the time being. We can go ahead and take it off, and then we'll get set up for the next operation. And it's on there tight. I might have to find my strap wrench. All right, I'm gonna get this off. We'll set up for the next operation. All right, we got this 6-inch piece of ductile iron chucked up in the lathe. And this 6-inch piece is about the limit of this 6-inch forejaw. I've already went ahead and faced one side, flipped it around, and used my mallet to seat it up against the chuck jaws. And I will go ahead and face this down to the final width, which is 3/4 of an inch. I'm actually going to leave it a little bit bigger than 3/4 of an inch. And this piece is sitting at about a hair over 1.25 inches. So we got about a 1/2 inch of material to take off of this face. So like I did before, I'm going to go ahead and start on camera, and then I'll turn the camera off and I'll finish it up, and we'll come back when it's done. I just wanted to point something out real quick. I wanted to say that, I meant to say this earlier, but ductile iron is much more enjoyable to work with than gray cast iron, because of the way that it forms a chip. See, if you see here, this is the ductile iron, and it actually makes, you know, a curly chip like everything, like most other materials do. However, the gray cast iron makes like this fine powder, and that fine powder is what gets all over the place, and it's just a pain to clean up. But the ductile iron, the chips are much more manageable and a lot easier to deal with. All right, we got this plate turned down to just over 3/4 of an inch. I left it about 15 thousandths oversized. That way I can do the final facing operation once we get the two pieces together and onto the spindle. What we're going to do now is drill and bore a profile into this plate that matches this backing plate that we machined earlier. We're first going to bore out this inner diameter, and then we're going to counter bore it with this larger diameter. And we want this to be not a real tight fit, but we don't want any slop in it, so that we can do this final facing operation and then also machine the register for the backing plate, and then turn the diameter down to the 5 inches of the chuck. All right, now we got a good fit on this inner diameter. There is no play, and that's what we want initially. And now we'll go ahead and cut the the counter bore for this outer diameter. And that's what we want, is a snug fit, because what we want to be able to do is to do all the rest of the operations with it on the adapter, so that we can make sure that it's all going to be concentric to the bore of the backing plate. And that'll do it for that. Now we're going to get set up on the drill press to drill and tap some holes for some bolts to hold the outer ring onto the adapter. All right, next we're going to drill the mounting holes to attach the outer ring to the inner adapter. I've already got the holes marked out. We're going to first center drill them, then we'll put the inner adapter inside the ring, and we'll drill all the way through with the tap drill size for a 5/16 18, which is a letter F drill. All right, and that put a hole all the way through into the inner adapter. Now what I'm going to do is I'm going to drill this hole out to the clearance size for the 5/16, and I'm going to tap this, and then we'll bolt it together so that I can drill the other. All right, I got the inner adapter mounted to the outer ring, held on with a single bolt. Now we can go ahead and drill these other two holes. This way, doing it this way, we can ensure that these holes are going to match up perfectly with the holes in the inner adapter. All right, off camera I went ahead and tapped those two holes, got the two pieces mounted together and onto the lathe. Now we can do our final operations, which is turning the diameter down to the chuck diameter, which is just under 5 inches. We'll face it off, and then we'll cut the register for the chuck. All right, we got the diameter cut down. Now we need to face this off to the final width, which is 3/4 of an inch. And we do have to be careful. I don't know if my bolts or my screws are going to be too long, and they are hardened, so I don't want to run into those. So I'll have to keep an eye on that. All right, the last turning operation we need to do is to turn the register for the chuck. Now the register diameter is just under 3 3/4 inches and to a total depth of 180 thousandths. All right, I don't have a set of micrometers that's large enough to measure this diameter. So what I had to do was get to close to the dimension and then make really light cuts, and kept checking it with the chuck to see if it would fit until I got it down to the final dimension. And we got a nice tight fit that doesn't have any play, and that's what you're looking for. Now that does it for the turning operations on the lathe. What we need to do now is take this back over to the bench, mark out the holes for mounting the plate to the chuck, drill those, and then we're almost done.